All right, now we're going to take a look at another type of sampling distribution. This is the sampling distribution of the sample proportion. So a proportion is a fraction or percent of the total that possess a certain characteristic. We have two different symbols that we can use to represent a proportion. For the population, the symbol that we use is a lowercase p. And for the sample proportion, we use a lowercase p, and then we put a little caret symbol on top of him. And we call this guy P hat, because he's wearing a little hat. He's so fancy. So to calculate the proportion, what we're going to do is we're going to take, I didn't leave myself a spot to do this. I'll put it over here. The proportion is calculated by taking the number that possess the characteristic, which we call x, divided by the total, which is n. So let's look at an example. The Harris Poll conducted a survey of 1,200 adult Americans who vacation during the summer, and they asked them whether they plan to work while on vacation. Of those surveyed, 552 said they plan to work while on vacation. Find the sample proportion of individuals who plan to work while on vacation. So we're looking for p hat because it's the sample proportion. And to find this, we're going to look for the number that plan to work while on vacation, and we're going to divide that by the number surveyed. And that is going to be x over n. So the number that plan to work is our x, and the number surveyed is our n. So 552 plan to work while they're on vacation, and 1,200 people were surveyed. So 552 divided by 1,200 is 0.46. Proportions are a lot like probabilities. They're not probabilities, but we want to think about the calculation similar in that our answer for a proportion is always going to be between 0 and 1. So this is the proportion. Now let's look at the sampling distribution. So if I take a sample over and over and over and over again, and I look at the proportion of people within that sample that have some sort of quality, what would that sampling distribution look like? So the central limit theorem for proportions, what tells us this is a normal distribution, that is n times p times 1 minus p has to be greater than or equal to 5. So our sample size times the population proportion times 1 minus the population proportion, that product has to be greater than or equal to 5. If it is, then we have a normal distribution. If it's not, then we don't have a normal distribution. The mean of all of the different proportions so the mean of all the sample proportions is equal to the population proportion P. And then the standard deviation of all of the different sample proportions is equal to the square root of P times 1 minus p divided by n. And notice this is a very large square root. All of this is inside the square root. And then the z-score for a proportion is p hat minus p divided by the square root of p times 1 minus p divided by n, which is the same formula that we just wrote down for the standard deviation of p hat. So if you've already found that, you don't have to calculate it again. So this is what the sampling distribution looks like. So let's look at an example. The Texas Workforce Commission reported that the state unemployment rate in March 2007 was 4.3%. Describe the sampling distribution of the sample proportion for unemployment with a sample of 250 people. So we're going to verify that we have a normal distribution, we're going to find mu of p hat, and we're going to find sigma of p hat. So the first thing we're going to do is make sure that we have a normal distribution. So to do that, we're going to do n times p times 1 minus p. And we want to make sure that that's greater than or equal to 5. So looking at the problem, my n is the sample of 250 people. And then the p is going to be the percent or the rate or the proportion that I've been given. So the unemployment rate in March 2007 was 4.3%. Now we can't math with percentages, so I'm going to rewrite p as 0.043, 4.3% as a decimal. So 250 is my n times 0.043 times 1 minus 0.043. And I want to see what that number is. Oopsies. And I got 10.29. So is 10.29 greater than or equal to 5? Why, yes, it is. Therefore, we have a normal distribution, which is great. I always draw a smiley face when we see that it's normal, because we need it to be normal. So then the second thing we're going to do is we are going to identify or find mu of p hat. So mu of p hat is equal to p. And our p in this case is 0.043. The 4.3% that we were given for the unemployment rate. And then the last thing we want to do is find sigma of p hat. Sigma of p hat is the square root of p times 1 minus p divided by n. So that's going to be the square root of 0.043 times 1 minus 0.043 divided by 250. And all of this is inside the square root. Now I can do this in my calculator all at once by doing square root and opening parentheses and doing 0.043 open parentheses 1 minus 0.043 close parentheses divided by 250 and then close the parentheses that opened with my square root. As long as I don't include any extra parentheses in there, this should work out, and I get 0.0128. And from this, I can see that I have a normal distribution with a mean of 0.043 and a standard deviation of 0.0128.